Good evening, ladies and gentlemen. I am Kino with STEMwithKino.com, and today is Aviation Selection Test Battery Weekly. This is the place where we get together for all those people preparing for the Coast Guard, United States Navy, and United States Marine Corps. Aviation Selection Test Battery, or the OAR. Okay, so it's kind of like has a dual purpose. All right. If you don't know me, I'm Kino from STEMwithKino.com, and we're going to go in. My Facebook people, I'm going to kind of, basically, the board is kind of, basically what, but you guys can see me. Jonathan, thanks for checking in. It's good to see you. Let's see what's going on the YouTube side of things. Okay, hold tight, and let me get on over to my channel. Okay, whether you're on YouTube or Facebook, please let me know where you're from and the test that you're preparing for. Your state, SIFT, OAR, all my SIFT people, AFOQT people, you're more than welcome to come in and present math and mechanical questions. Okay, I just thought, oh man, you're a SIFT guy. No, I'm not talking to you. No. Time I'm posting, if there's any math that you don't understand, if there's any, mechanical comprehension concepts you don't understand, feel free on any live stream that I do. You're more than welcome. Just trying to see here. Facebook has changed up their format, so things are looking very, very unusual. But that's okay. They have some new setup here, and that's all right. I'm just going to roll with it. And here we are, folks. Okay, so way that you can deliver questions. If you're already if you're already a student of mine, you can send the messages directly through Skype. If you're not a student of mine, you can send your questions to STEMwithKino.com. And for my YouTubers, if you're not already following me on Facebook, I will put the link in a moment here. Let me just reduce this window a little bit. And paste. Bang. Okay, so you guys got the email. If you already follow me on Facebook, you guys can post directly on the page, on the STEMwithKino.com page, and we can get underway. Couple things I want to address specifically. Like I said, I'm going to start focusing on some enabling objective topics. So give me a moment. Let me get there. And no, I went in too far. There we go. Alrighty. Alright, and why don't we do weather? Yeah, we almost never do weather. Okay. We almost never do weather. Alright, so in aviation pre-flight indoctrination, there's 5 major areas that you will need to familiarize yourself with. And the meteorology is one of them. Okay. Just enabling your objective. All right. And I will kind of post this copy. And let me see here. See if I can, I'm sorry, I'm looking around stuff, guys. All right. The characteristics of the troposphere. Let me put this on the Facebook, can I? Yeah. Paste. Okay. Save post. No, I'm gonna save it when I post it. Alright, I guess save post is what drops it on. Okay. Oh, there we go. Alright. Thanks. Alright. Characteristics of the troposphere. Okay. As a pilot, you are going to need to know about the troposphere and everything that it does. First, let's examine the word troposphere. Trope. I don't know if it's the Latin or the Greek word, really doesn't matter, but I won't say it doesn't matter, but the root word trop or trope means to change. Okay, and out of all the layers of the atmosphere, this is the one that has a lot of changes in it. And that's the reason why it drives the weather, because you get weather because of temperature differences. If you look at your high pressure areas and low pressure areas, well, there's temperature changes that are causing that. So the solar radiations, solar radiation comes from the sun, strikes different parts of the planet, and you have different temperatures, and then as a result, you get higher and lower temperatures. For our purposes, or for you guys that are going to API and you're going to actually have to take the Federal Aviation Administration private pilot exam, what you should know is that there's something called a standard lapse rate. A standard lapse rate. Okay. And even before we go into that, what we need to talk about are standard temperature. Well, there's standard numbers for the atmosphere. At sea level, it is supposed to be 15 degrees Celsius, 59 degrees Fahrenheit. The atmospheric pressure is supposed to be 29.92 inches of mercury, or 1013.2 millibars. All right. So those are some numbers that. And why do we come up with this standard atmosphere? Because the atmosphere is almost never just standard. Like, oh my God, I'm at sea level. It's 59 degrees Fahrenheit. I can never, ever remember a time being at sea level and it was 59 degrees Fahrenheit. So why would we do this? The instruments, the pedostatic instruments are calibrated according to those numbers. And so as a result, this is that perfect atmosphere that exists. So when there's changes in that perfect atmosphere, then the instruments say, hey, this is not standard. So, so you get changes like in your altimeter. As you increase altitude, your pressure decreases, and so as a result, what happens is should I go this way? Well, facing me, the altimeter will be going this way, clockwise. If you were in a descent, it will be going counterclockwise, like your vertical speed indicator. When it senses a change in atmospheric pressure, it indicates if you're climbing, it will show you an increase. If it's level, no change, it will sit at 0. And then if we go into a descent, it will go downward. Okay. So that standard atmosphere is what the weather and what the atmosphere numbers are supposed to be doing at sea level. And the instruments are calibrated as such. Okay. So we didn't talk about standard lapse rate. Okay. Standard lapse rate is 2 degrees Celsius or 3.5 degrees Fahrenheit. So you take your base numbers, your 15 degrees Celsius, 59 degrees Fahrenheit at sea level. We are supposed to lose 2 degrees per 1,000 feet, or we're supposed to lose 3.5 degrees per 1,000 feet, degrees Fahrenheit per 1,000 feet. So on the Celsius scale, if you went from sea level and you flew to 1,000 feet above sea level, well, your temperature is supposed to be 13 degrees Celsius at that point. If you go to 2,000 feet, your temperature is supposed to be 11 degrees at that particular altitude. In a perfect atmosphere, which, like I said, almost never exists. Okay, so standard lapse rate. The troposphere is actually kind of egg-shaped. Let me demonstrate. It's kind of egg-shaped. So if we took our planet and we looked at the equator, North Pole, South Pole, okay, the troposphere would kind of look like this almost. All right. So at the poles, you want to say it's about 29,000 feet. And at the equatorial regions, it could be anywhere like 35. Let's just say 35,000 feet. All right. And you have to look at the expansion of air. At the polar regions, it's colder, so the molecules are squeezed closer together. And the equatorial regions, where it's warm, then the molecules spread apart. So that change in temperature, that's the lapse rate. Okay. And one of the one of many telltale signs for thunderstorm development is what we call a temperature inversion. So instead of getting colder as we went up, it would get warmer as we went up, which would indicate some type of circulation. All right. So, we almost never, ever do anything concerning weather. So I'm trying to hit as many types of enabling objectives as I can. And let's talk about cockpit thrust measuring devices. I like this one. Cockpit thrust measuring devices. Now, thrust measuring devices. I'm going to do a little bit of background because I want to make sure that you get the full meat and potatoes of what that means, but thrust measuring devices. Well, I don't want to go into turbine stuff. We'll leave that alone. Because I really want to, have like a step-by-step, point-by-point to make sure you guys get everything. So I don't want to, in other words, I don't want to half-ass it. That's my point. Okay. Let's talk about, if we're going to talk about engines and stuff like that, let's talk about the 4 stages in a turbine versus the 4 stages in a reciprocating engine aircraft. Okay, so or we'll just leave it to the the turbine, and then next week we'll just add some more. Okay, so all right, I want to go to Google and I want to get an image so we can post it on our post on the Facebook page. Okay, so turbine engine. Very good images, beautiful images. Okay. All right. So if you look at this graphic, and this graphic is from who's it? ICYM. I don't know who they are, but ICYM. All right. And you have to be following me on Facebook in order to see this image. Where are you? You. All right. For some reason, whatever reason, all right. Facebook. I talk to my computer, but I don't answer back, guys. Okay, so, all right, here we go. Here's the page, and I'm going to the post page, and after this, we'll get into questions. So if you look at this graphic, it's going to be a turbine engine, and you're going to notice 4 sections. and we're going to talk a little bit about what happens. You can see the caption, gas turbine engine, how does it work? Well, if we look at this gas turbine engine, and you can actually, if you're on YouTube and you want to open up another window and just Google gas turbine engine, what you'll notice is that there are 4 sections. If you're not on Facebook and you can't follow me on Facebook. All right, so the gas turbine engine, how it works. Okay. What you'll notice if you are following me on Facebook, you'll see an intake area. You'll see some fans, and this is where the air is sucked in. And then you'll see the blades get tighter and tighter and tighter or closer together. This is where the air is compressed. In the combustion chamber, we introduce fuel. And so we spray that fuel in there and we get a combustion. Now, with this heat expansion of air and all this and everything, and my SIFT people, most of your helicopters are turbine powered. Okay, so you want to be familiar with this as well. So fuel is sprayed into the combustion chamber with that compressed air, and then it's heated up and we get expansion, and then it blows out the back, like kind of sort of like think of that combustion like a balloon being filled up, and then it's just released out the back, and then you get pushed. Okay, normally there is a connection between the rearward part of the turbine and the forward part. So as long as we have expansion out the back, it'll keep turning the fans up forward, and the only thing that would really stop the engine is like a compression stall or running out of fuel. Okay, so if you guys see the image, even whether you're on Facebook or YouTube, type 1 for me. And then we'll get into questions here. DRG, are you in the building? I want to know if you figured it out because I told you I was going to do your question first. Jonathan, I see your question as well. Okay. All right. Yeah, I see your question as well. It's a pulley question. All right. So I had a in DRG in there. Let me see if he's in here. I told him don't be late. Okay, I see him. Quanisha C, Specialist Slam. I see you as well. Thanks for checking in, Jonathan. I see you as well. Thank you, Austin. I see you as well. Thanks for checking in. All right. So, well, let me present the problem so everybody can see it. Yeah, I'm gonna have to make an adjustment on this camera because it should be kind of like thrown off to the left, so I don't have to do a little, for like them. What was that move? The snake or something? We used to call it when we were kids. All right. On Facebook, closing that and posting the question. All right. In word problems, we have to have the ability to take words and change them into some type of math format in order to get the point. All right. So, DRG, what was your answer to this? You said you think you found it out. Let's type it in there. We'll give DRG a moment. We were working on this earlier, and we had a couple barriers there. That is the answer. Good job. You figured it out. All right, so I posted it on Facebook. Basically, what the question is saying is it's find the area of a square circumscribed about a circle whose radius is 10. So basically we have a square And I'm going to attempt to draw a perfect circle, which never ever works out. But this is intended to be a perfect circle within the square. And the radius is supposed to be 10. And they're asking us to find the area of the triangle. All right. And Aaron already answered it, so there's no use of being like, oh, well, let's see who gets it. Basically, if the circle is the center of this square, then the distance across on one side is 20. And they're asking us for the area, which is length times width. 2 times 2 is 4, and then add the 2 zeros. So 400 square units. You know, if they said 10 feet, you would pick 400 square feet. If they said the radius was 10 inches, it would be 400 square inches. Units are very, very, very important. And it's not uncommon for a test to be like, okay, well, 400 units, 400 feet, 400 square feet. And based on this, if you saw 10 feet as a radius, then you would say 400 square feet. So you want to be very, very careful how you answer these questions. Another thing, if you can stand it, you do not want to be taking 5 minutes. I say this every week. 5 minutes on one question is unacceptable. You're going to have to practice and drill and, yourself to the point where you can just look at a question. You want to try to get it burnt or done in 60 seconds. If you can't get it done in 60 seconds, it's something you need to work on. Do they always happen in 60 seconds? No, but I recommend 60 seconds because it allots time for you to answer those harder questions. Because some questions are going to be easy. You're going to be like, bop, 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 bop. You're going to knock them right off. But then some may take a little bit more time. So if you try to focus on that 60-second attack on questions, then it should allow you more time. The objective is to see all the questions that they present to you. So if you take 5 minutes per question, you'll only see about 6 of the questions. Would you rather have see 6 or 25 and, have more of more of a probability of, scoring higher? So just things we should, so good job, DRG. You found the answer. Because I said, look, I'll just do it in a live stream. And, Quanisha, didn't you send me some questions? That I said I'm going to do this week. And you can answer yes or no. If I know you sent me some questions, and I'm looking on our timeline because definitely want to get these out. I'm not sure if you emailed them to me or no. I guess you didn't. Let me check my Gmail real quick, guys. I'm trying to make this as speedy as possible. Yeah. And you sent it to my email, right? I think you sent it to my email. All right. There's only one way to fix that. And I have an image from last week. Oh, okay. We did that question. That was the triangle ratio one. Okay. All right. I just wanted to make sure I wasn't leaving you out. You know what I'm saying? Because you'd be like, don't never answer my question. No, I know you wouldn't say that. I'm being me. Okay. All right. As far as pulley systems, okay. Let's expand this and let's drop this on the Facebook timeline. Pulley questions. Okay, the picture went away. Jonathan, your picture's evasive. All right. You will see, and I'll draw this out on the board as well for my YouTubers, but you're going to see 2 situations with pulleys. And they're going to ask you, well, which one is the easiest to raise the weight? And I'm going to demonstrate. All right, I'm dropping this on the post page. And all my civic people, this is need to know information, mechanical comprehension, pulley systems. All right, it is posting right now. Okay, so basically what we have is a situation where we have two pulleys. And we're assuming that they're the same weight. Um, let's see, so let's say this is 50 pounds, and we have a ceiling, and we have a fixed pulley. It's fixed, it's not movable. And basically, the rope or the chain comes around, and then we pull down to raise the weight. We will pull this down to raise the weight. The other situation is situation A. In situation B, this is attached to the wall, and you're actually going to pull this upward, but this is a movable pulley, but it's still 50 pounds. All right. So you're going to pull downward on this one, and you're going to pull upward on this one. And I'd like some group participation. Which one do you think is going to be easier to pull? This guy, A or B? Type in A or B in the chat for me, guys. Please. Situation A, someone comes in with situation A. Okay, somebody two come in with A. Do we have a B? Does anybody have a B? Well, everybody else scared? Don't be scared. Okay, we got another A. Oh, and if please, YouTubers, please hit the like button for me. It's free. I mean, you go to my website, channel support, if you want to donate to the cause of my channel, if you like. But if you, hey, why not? It's on the website, stemwithkino.com, and it is channel support or support page, something like that. And there's different little donations you can make if you want to. Okay, we got A's, predominantly A's. And I have some really bad news, guys. You're all wrong, all wrong, all wrong. I know, I'm sorry. Yeah, you're all wrong. Okay. Think about the mechanical advantage of a pulley system, all right? A fixed pulley gives you a mechanical advantage of 1. Now, technically, it's no mechanical advantage. The mechanical advantage is if I use 50 pounds of force and I get 200 pounds of effort out of it, all right? That's what a simple machine is supposed to do. But in this case, the fixed movable pulley only has a mechanical advantage of 1. This movable pulley has a mechanical advantage of, you got to think, this is supporting it in a sense, and this is rolling, and it's lifting as well. So this is just kind of support. It is rolling, but it's really not in support of actually, helping the oomph, the strength or mechanical advantage. So a movable pulley will always have more mechanical advantage than a single fixed pulley. Think about your flagpole. On the flagpole, you have a single fixed pulley up top. And then you have the rope coming down like this. So when you're raising your flag, all right, you're just reversing the direction of your effort. It's a mechanical advantage of 1, which means if I put in 20 pounds of pull, I'm only going to get 20 pounds of effort. Which this is not the case. Now, am I calculating what it is? No, but it's better than a fixed pulley because a fixed pulley only has a mechanical advantage of 1. And if everybody understands that, or if I need to clarify that even further, please, if you understood, just press 1. If you didn't, press 2. But a single fixed pulley only changes the direction of your effort. You don't get a mechanical advantage, or numerically we say it's a mechanical advantage of 1. So we can't say no mechanical advantage, but it's just 1. It's really not, leveraging, giving us more than what we put in. All right. All right. And same thing. That's really like the same type of question, Jonathan. On the other one, it's just on a slant instead of vertical. Same thing. The second one is easier to pull. Mm-mm-mm. Good job for figuring out that question, DRG. Let's see. And tell your recruiters. Talk to your recruiters. Tell your recruiters, hey, it's this crazy guy on YouTube, man. He helps us figure out aviation selection test battery questions and questions for the officer aptitude rating for the United States Navy, Coast Guard, and Marine Corps. Okay. I'm sifting through some more questions. Actually, it's a little bit. Mm, all right, back out. And we'll talk about boating or nautical terms. I may have touched on this, but I just want to get this out of the way to be sure. These are definitely terms that you should know, and I may have touched on them, but I just want to be sure. I don't want to be like, oh, did I talk about that? I want to know so when the question comes up, I can tell you, okay, you got to refer to another video. All right, so all right, now looking for seeing the image I want. All right, freeboard, draft, and waterline. Very good. Oh, okay. I have a really cool image for nautical terms that you guys should. All right. Did you send it to my? I saw your post, what you just posted. Did you send that to my my Gmail? Okay. Cool. Good to see you, Mike. Oh, 3, 7. All right. I'm probably gonna do it. Remind me of this, Michael. But I'm probably gonna do a series on this because I don't. I want to put people in a position where they can answer this because this comes in many different shades when we talk about like the terms in the sequence, and we have to identify like common ratio and all that and everything like that. So that's probably a little bit longer. But then what I would do is start a series on that next week. But yeah, find the nth term. All right. So if you're on the Facebook page, we have ooh, She ain't playing, but she sent the beast. All right, let me see here. 8, you would not see number 8. You wouldn't see number 8 on the test. You would see 7. And direction B. All right, so yeah, let me come back to the nautical terms. If you're following me on Facebook, on the Facebook post page, you should see the boat in the water, and water line is pretty much the part of the ship where the water is. The water line down to the bottom of the keel is called the draft, and the freeboard is from the water line up to the top part of the ship, or the upper deck. Okay, so water line, freeboard, draft. Got some nautical terms in there. Good, very good. And let's look at Juanisha's question. So we're coming back, and no, she sent that in Gmail. And let's see here. There we go. All right. I want you guys to type 1 in the Facebook on the Facebook side of things if you can see this question. I'm presenting it on the post page now. Yeah, it was, and you won't see that. That's another thing. You need somebody that tutors these things, because a lot of times, I'm not saying Trivium is a bad book, but I feel, in my experience, I don't think Trivium is their books on the ASTB, on the SIFT. They do a pretty good job on the SIFT. But on the aviation selection test party, I don't feel like it's representative of a lot of the things that you would see on the test. So, some guy, I could publish a book and have super hard questions on there, and you won't see those types. And so that's what that is a example of, Juanisha. All right, the picture is posted on Facebook, and if we look at this thing, we should talk about forces. Okay, a basketball practice machine contains 6 baskets, and a baseball practice machine contains 6 baskets, and each basket contains a baseball. The machine rotates counterclockwise and releases each ball at point 1. So wow, it is kind of in a turn when it does that. Which direction does the ball travel after being released by the machine? Okay, so you can see 2 forces, Alpha and Charlie, and then Bravo is the resultant force. So it's going to go in direction B. You can see that because centrifugal and centripetal force is acting on each basket and holding that ball in there. So, guys, just think of a machine that has a basket, right? And the basket is here and it's holding a baseball, right? And so when this ball gets around here, it's going to release it, all right? And they show you a force alpha and a force bravo with equal lines, so that means that the magnitude is the same. And then we see a resultant vector in B. So they're asking, when the ball gets here, is it going to shoot this way towards Charlie? Sorry. Is it going to go straight with Bravo? Or is it going to go towards Alpha? Now, while this thing is in this turn, so to speak. There are two forces that are acting on it. Anything, if I take anything and I twirl it around, there's a force that wants to keep it turning in. That is the centripetal force. Kind of like centripetal, that's how it's spelled. Centripetal, that's how it sounds. And centrifugal force pushes us to the outside of the turn. All right, so if these are a balance, it should go straight. It's kind of like if you saw those movies when they have those bolos and you're swinging it around, you're turning it, but that last little bit of centripetal force balanced with centrifugal force makes the bolo, I think you call it, go forward. So I would go with B. Let's go on position B. Four bracing positions are shown. Say which is the most likely to provide the most strength. The one in the middle. All right. If I had a 2 foot by 2 foot, oh yeah, the 90 degree. Well, no, I've seen this question in different ways, and I am definitely gonna research this, but I don't know. I think I might go with the because shelving is never. Hold on, inclined plane, mechanical advantage. Okay. I'm gonna go with alpha. Let me look at mechanical advantage first. 3 and 9. Mechanical advantage 3. 4 and 12. That's still a mechanical advantage of 3. 4. Let's say 16 and 4. More distance. 4. All right, Quenisha, I'm going to do some research on this because I have not seen this question like this before. I've seen it where they had to break it in and then out a little bit and out a little bit more, but I will definitely get back to you on either our one-on-one sessions or. But I just don't want to give you bad information. I don't want to give you bad information. So we'll just put that on ice for now, but we will definitely address it. All right. Right. If you're just checking in on YouTube, please hit the like button. All right. Let's see here. Let's not leave my second one. I was interested. The example on the left is less force. It's a fixed belief. Yeah. Yeah. Jonathan, I'm just looking at this. Um, yeah. You're getting additional help, and we'll talk about this on our one-on-one. Because I've seen that question so many times, it's crazy. All right. All right. Let's talk about another aviation and nautical term: navigation lights. Did you know that airplanes? All right, let me. Nice airplane. Don't laugh at my artwork, guys. I'm very sensitive about my artwork. So airplanes and boats or ships have navigation lights on them. This is for nighttime operations, and it's for collision avoidance. All right. If you, let me see if I can be. Yeah. If we look at, and when you guys start looking at airplanes and boats now, you'll see this. On the right wingtip, there's a green light. Right side of the boat, green light. Sometimes they just position them here. On the left side is a red light, and on the tail it is a white light. I'll just put WHT. WHT. All right. This is for, even if you can't see the ship or the airplane, you can see the navigation lights. All right. So if I'm following behind an airplane, and another thing, most airplanes will have a strobe. Those lights are just white lights, flash off, flash off, flash. Sometimes they flash, 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 flash. It's more like helicopters. But you'll have strobe lights. Those are the strobe lights. They just kind of on, off, on, off, on, off, or some type of flashing pattern. Okay, but you'll see steady lights on the aircraft or watercraft, and it should be a green light on the right hand side. It should be a red light on the left side, and you should have a white light on the tail. All right. So if I see a green light going from my left to right, like this is us, and we're looking at a cockpit, or we're looking from a watercraft off the bridge, and I see a green light going this way, then I know that the ship is going that way, or I'm looking at the right side of the ship. Conversely, if it's going this way and moving from this side to this side, I know that ship is moving in that direction. Yeah, because you see the movement, but you'll also see the red light to confirm that is the left side of the ship. Sorry, and if it's heading away from you, you should see the white light. Airplanes are kind of a little bit different because they have a strobe effect. Okay, but I think that's more of a better environment because you get that flash to say, hey, look, I'm here. Hey, look, I'm here. Because typically, once we climb up and we get into our cruise, we retract our gear, and you can't see our landing lights anymore if they're on the nose gear, or if they're like kind of in the wings. Some landing lights are on the wings, or you may have wing lights. We typically turn those off because in the cockpit, especially at night, I want it to be very, very nice and dark as comfortably possible. Because any bright lights is going to really like distort our night vision. It's going to jack us up a little bit. So, I know I have Nick, and then went. Okay. So, yeah, I got a lot of sessions in, had a lot of like good weeks. I really didn't see too many deficiencies in my people, which was good. Everybody's pretty sharp for the most part, and that's good. Sometimes I have people that are just like, they don't get it, they don't really have a clue, and I'm not really talking about them. It's just a little bit harder work because I gotta kind of go hard in teaching them. But pretty much, I don't really see anybody here, any of my people that you guys are progressing very, very well, all of you. Um, Let me see. I'm just checking for any quick questions to make sure that I kind of addressed everybody's question. It must be busy. I haven't really gotten one. Normally, my deployed people send me questions, but I guess it's been really, really busy for you guys out there. But we thank you guys for all you're doing out there. Stay safe, not only from hurt, harm, and danger, but now, the CV is like all over the place, all over the planet. So yeah, protect yourselves from that as well too. But yeah, again, we thank you guys for your service out there, and feel free to send questions. Also, yeah, let your recruiters know. Hey, I'm just hanging out with you guys, answering questions. Ask away. All right. Only a couple people checked in, but guys, make sure you check in. It's just feedback. I like to know what areas I'm hitting. What I may not be tutoring with you, but hey, hey, I'm taking the OAR. Hey, I'm taking the full aviation selection test battery, or hey, I'm taking the SIF. Let's see. My buddy DRG. In the ninth inning, he drops the question. I got you, brother. Okay, so in this question we have a tank, and you didn't give me any questions, but that's all right. I'll answer it anyway. Let's see, difficult. All right, all right, all right, all right, all right. All right, I'll put this on the Facebook page. Kill that, and I'm posting it now. And YouTubers, hold on tight. I will show you guys what we're looking at. All right. Okay, so basically what we have is and he didn't indicate any multiple choice answers. I kind of see one, but okay. An 8-inch level indicates 16 quarts of oil. All right, so if we had 8 inches, that would tell us that we have 16 quarts of oil. Okay, that is a standard. Sometimes we can use a standard for proportions if we want to set up something here. So 8 inches is 16 quarts. So we have an inch to quart relationship. All right. So 8-inch level indicates 16 quarts of oil. If an 8-inch level tells us we have 16 quarts, then the number of quarts of oil to be added to raise the level from 6 to 8 is how many quarts? Well, 8 inches of space gives us 16 quarts. Now, if we were supposedly at 6 inches and needed to raise 8, then we would have to add how many quarts? So I'm not even going to focus on so much the 6 even, because we're going to raise, if they're saying hypothetically, if we needed to raise the level from 6 to 8 quarts, then I'm going to say 2 inches, because 6 to 8 is 2 inches. So if 8 inches has 16 quarts, then 2 inches has X amount of quarts. So I immediately see that as 4 quarts, because 2 times 16 is 32 divided by 8. We cross multiply and then divide with proportions. Okay, so 6 meant nothing to me, because it's just like, okay, we got to raise it from 6 to 8, a 2-inch level. So our standard in this proportion was 8 inches is 16 quarts. So how many quarts are we going to have to add to raise our level from 6 to 8 inches, which is 2 inches? I want to know how many quarts are in 2 inches. So 2 times 16, 32 divided by 8, 4, done. And you can do that in less than 60 seconds. And type 1 if you guys understood everything I did there. And Darren, thanks for the question. Thank you for the question, buddy. He's my buddy. He's always sending me. So yeah, Keno, solve this. Okay. So for all you guys that don't know, I also do a SIFT. Even if you're OAR tomorrow at 2 p.m. Eastern, even if you're OAR and ASTBE, you can still bring math and mechanical questions to that session. I'm not gonna be like, oh no, you're Navy, like no, you're Marine Corps, no, I can't answer that math question. No, come to the session, bring your questions. I don't think you guys get enough out of this, man. You know, hammer me with questions. He's asking for it. All right. So I hope somebody learned something. I hope everybody learned something. Again, there's only 2 minutes in the chat. I'm Keno with STEMwithKeno.com. If you don't tutor with me, you want to make a donation to the channel, feel free. You can go to STEMwithKeno.com, go to our channel support page, and there's different denominations you can, help us out with the channel to keep the Keno train going. And all my students, I will see you during your respective days and times. But thanks for watching. Please share this on your social media network. If you're in a ROTC unit, Navy, Marine Corps, ROTC, boom, just let them know, like, hey, this is the sky. It's a little crazy, but he answers questions concerning this test. Because you really, really want to score high on this so you can get selected, especially my aviation guys. You know, it's tough out here, you know, if you're not set up properly. So again, we are at 5:59, guys. I thank you guys for checking me out. Please come to the SIFT session tomorrow if you're not doing anything, 2 p.m. Eastern. That's really all I have, guys. I can't think of anything else I want to mention. And Nick, I will see you in about an hour. And then once I will see you an hour after that. So 7 p.m. and 8 p.m. appointments I have. I still have work to do. My day is not over. It's never over. So to my Facebook people, I was almost to my Facebook people. I almost felt like Obama. To my Facebook people, I don't know if this sounds like him, but and Facebook. I'll see you guys later. Thanks for checking in, everybody. Also, if you guys need tutoring, reach out to me via Facebook or Gmail. All right, and YouTube. I will see you guys later.